All right, so we have a problem. Central angle is 5 pi over 6,
Yes.
and the arc length is 10x, right? Or the arc measure is 10x.
No, 10 pi.
10 pi, okay. That's the arc length, right?
Yeah.
Okay, what is the question?
What is the length of the radius?
Okay. So first of all, let's talk about what radians are, okay? Now, radians basically is another way to measure an angle or curvature. So one way we can measure angles or the curvature of an arc is in degrees. The other way is radians. And the conversion factor is pi over 180, okay? So if I want to go from degrees to radians, right? I take the degree, multiply by pi over 180, and I'll get the radians. Now, if I want to go from radians to degrees, I take the measure in radians and multiply it by 180 divided by pi, okay? Now, depends on what you're given, the formula, depending on what you're given, the formula for arc length is different, okay? So remember we were given the arc length being the arc length was the circumference times the angle measure divided by 360, okay? That was the arc length, the formula that I gave you in class. Now, if you have the measure in radians, so this is measured in degrees. Now, if you're given in radians, the arc length is simply the radius times the angle measure, but the angle measure is measured in radians. Okay. So let's look at this problem. So the arc length is 10 pi, and it's the radius times the angle. Remember, this theta is a variable to represent the angle. And the angle in radians is 5 pi over 6, okay? Maddie, are you still with me?
Yeah.
All right. Have I confused you anywhere in my discussion?
A little bit, but like I think I'm starting to get back on track. So like
Okay, so
I'm figuring it out.
Where did I give you a problem? Where was the hold up?
What's the whole D arrow R like?
Okay, so remember we said the angle. Okay, so let me repeat from the beginning. So radians is another way to measure something, some angle or the curvature of an arc.
Okay. I should probably take that.
So remember we measured the angles in degrees in class. The other way to do it is radians, okay? So there's a conversion factor. So if I gave you something in degrees, to find the radian measure, you would multiply it by pi over 180. So let's do an example first. Let's say I have something that is, say, 18 degrees. How many radians is that? So
18?
No, you multiply that by pi over 180, okay? You get 18 pi over 180, and the 18 over 180 can be reduced to 1 over 10. So it's pi 10. So 18 degrees is equivalent to pi over 10 radians. It's just a way of converting it. It's like no different than when you're measuring length. You can measure it in feet or you can measure it in meters, okay?
Mm-hmm.
You can measure something in ounces or in gallons. So you can measure an angle in degrees or in radians. Now, let's say, for example, I have something in radian measure. So I have something that's pi over 3 radians. And I want to know how many degrees is it. Well,
You do the opposite.
you do the opposite, which is 180 over pi. So that's 180 pi over 3 pi. The pi's
Doesn't the pi
cancel.
just cancel out? Yeah.
Right. So 180 over 3 becomes 60. So that's
60.
60 degrees. Yeah.
Okay, I get it when you like go from the radians to the degrees. Like that makes sense.
Okay. Now, here we go. So we have an angle is 5 pi over 6. Okay. Just remember, this is just another way of measuring an angle. And we know the arc measure is 10 pi. And we want to know the arc length is 10 pi. And we want to know the radius. Now I said, depending on what units your angle is in, the arc length has a different formulas. So the arc length, the formula that I gave you was the circumference times the angle, the circumference times the angle over 360. Okay.
Okay.
Now that's if the angle is measured in degrees. If the angle is not measured in degrees and rather it's measured in radians,
It is.
it's just radius times theta.
Okay.
All right. So the way you know it's in degrees is if there's no pi. If it is not, if you have a like something in pi units, like 5 pi over 6 or 10 pi, then you know it's measured using radians. Okay. So 10 pi is my arc length. Radius is what I'm looking for. This is my angle, and my angle is 5 pi over 6. So how do I find the radius? Well, I'll divide both sides by 5 pi over 6. Now remember, when you divide by a fraction, you're actually multiplying by its reciprocal. So the reciprocal of 5 pi over 6 is 6 over 5 pi. So that's 60 pi over 5 pi gives you a radius of 12.
Cool.
Mhm.
That was right. That was the right answer.
Mhm. Hopefully,
It was.
you know, I'm not that good at math, so
You
hopefully it
stop.
worked out.
It's talking. It's talking. I hate how it makes you listen to everything before like.
Well, thank God it worked out, because God knows my math skills have a lot to be desired. So, okay, Miss Lee, did I answer your question, or did you have another question?
Hold on. Can you hear me?
Yes.
Okay. I thought I was muted. This is my question.
Sure.
I understand, of course, when you just explained it, other than dividing through by all the pies and all that. But anyway, I get the
Usually pi is a
what
good
you
thing,
do.
but oh well.
Finding arc length with a central angle measured in radians. I get it when it's on the instruction and on the assignment, but on the quiz, it's asked several times. Within which range is the radian measure of the central angle? And
Can you give me a
Error.
picture of the question, and then I can maybe walk us through it?
Let's see. Hold on. Give me.
Or you can snapshot and text it to me if you'd like.
Okay, yeah. Let me shrink everybody. Hold on.
So usually, you know, we don't really bring this up until, I mean, the problem is, many students are like, well, why didn't you talk about this in class? Well, the reason is because if this was an advanced geometry class, then maybe I would have. And because I knew if I was in advanced geometry, the lion's share of my students will be going into algebra 2 or trig. But because over 70% of my students are going to be going to, like, what's that? The next level.
Algebra with finance.
Algebra with finance, or whatever the next thing is, algebraic connections. They don't really talk about this. So, why inject a level of complications when it's not really going to be encountered anymore? So
I agree. I think it's a highly not cool. Okay, hold on.
Wait,
cool is a relative term. I think it's cool.
Oh, wait. Hold on. I'm on the wrong. I'm trying to get back to the circumference lesson. Crud. Let me get in as a, wait, let me, I've got to get in as a student to get to the one that I did.
Mm-hmm.
Thank the Lord I'm married to a former math teacher. He had to help me out a couple of times. Yeah, oh my gosh.
You are in the correct profession.
Okay, winter.
I'm literally just gonna quit this and wait till I get to go to my dad's house in 2 days and just do it all there.
Why?
Because he does math.
By the
I
way,
don't.
it's quite behind. Oh, by the way, while Miss Lee's looking it up, everyone needs to know, every grade that you have turned in up to me by now, all of the grades have been uploaded to iNow. If you go to iNow, each minor grade and major grade is listed on how it's calculated. So for example, you'll see like circles, quizzes 1 and 2. So that means that grade will be calculated using quizzes 1 and 2. So if you have not done those quizzes, or if you are in the middle of a retake, I've not put the grade in because you've not done one of them. Now, this is important. Everyone has till the end of next week. So not this Sunday, but the next Sunday, to get all the grades in. As of next Sunday, whatever grades I don't have, all those blanks that you see are going to go zeros, and that's going to kill most of your grades. So make sure that the grades are in.
Okay, I sent it to you.
I'll get caught up.
All right. So this talks about the relationship basically between angles, degrees, and radians. Okay. So I don't know if you caught the tail end of it, but we talked about converting degrees into radians. And,
yes.
So let's convert some degrees into radians. So let's do 90 degrees. So that's pi over 180, because I'm converting degrees to radians. So this is 90 pi divided by 180. 90 over 180 becomes 1/2. So 90 is pi over 2. Okay. Now, 180 degrees we do the same thing. We get 180 pi over 180, which is just pi. Okay. 270 degrees, do the same math. So 270 pi over 180 can be reduced to 27 pi over 18, which 27 over 18 can be further reduced because they both are a factor of 9, multiple of 9. So we can factor out a 9 and we can get 3 pi over 2. Okay. Last one I want to do is 360 degrees. That's 2 pi. Now, Maddie, how many degrees are in a circle?
360.
360, good. So let's do this. Let's take a coordinate plane. Okay. Now, what I'm going to do to this coordinate plane is put a circle on it, where the center of the circle is at 0, 0. Okay.
Oh, that's satisfying. It's like right in the middle.
Is what?
I said it looks good 'cause it's like right in the middle.
Okay. Thank God for autocorrection, right?
Right.
Yeah.
I have another question when you're done explaining this one.
So let's look at what happens here. Let's start off. So when we measure something, when we measure an angle, we measure it in a counterclockwise direction. So we didn't talk about how to measure angles in this class, but when you measure an angle, you take your protractor. I think it's a protractor, or is it a compass? I always get the two mixed up. The thing that looks like a half circle. Anyhow, is that a protractor? I don't know. It's just
the thing that looks like the what?
half circle. It looks like a happy face.
Yeah, that's a protractor.
Is that what it called? I always get the two confused, compass and protractor.
The compass is the thing you could stab somebody with.
Yeah.
You know, it's the pointy thing.
I don't know. Anyhow, the way
I
you
thought
would
a compass was like north, south, east, west.
You would put the horizontal piece on the horizontal line, and then you would measure in a counterclockwise direction. Okay. Measure in a counterclockwise direction, and that will give you your degree. So if you put this little angle that I just drew, you'd put the protractor on the little horizontal line, and then you'd say, okay, how many degrees is the space in between? Now, let's do the same thing for this circle. Okay, it's on a coordinate plane. So what angle measure is this?
90.
90. But what did we say 90 was? It was,
All right.
well, how many radians is it? Remember, we converted 90 degrees
Pi
to
over 2.
pi over 2, right.
I was waiting on you to scroll up.
Now, if I go all the way to the other side, how many degrees is that?
180.
180, which is
Or-
how many radians?
Go one scroll up.
How many radians is 180 degrees?
3 pi over, no, that's
No.
pi.
It's pi, yeah. Okay, so pi.
I almost went for 3 pi over 2.
Okay, so let's just do this. This is 90 degrees. This is 180 degrees, okay? Now, let's go all the way down to here. How many degrees are we at?
3 pi over 2.
Which is
Or 270.
Right. Okay. And if we go all the way back, so if we start off here, it would be 0 degrees, but if we go all the way back, that's 360 degrees, which is 2 pi.
2 pi.
Okay. So depending on where how big your angle is, it can fall in one of these ranges, okay? So if you take an angle, so say for example, I take an angle that is, say this guy, right? Which is 45 degrees.
Okay.
If I put him on the coordinate plane, the way I do it is I put the vertex on 0, 0, and I put the horizontal line on the positive x-axis, and then I let the angle fall where it will fall like right here. Okay, so between which radians is it? Well, 0 and pi over 2 radians.
90.
Yeah. Now, let's go back to
Okay.
the question that we have. It's 295. Well, if it's 295, the angle is going to go from here all the way to something like right here, because it's larger than 270 but less than 360.
Mm-hmm.
So between which two radian measures does it lie? It is greater than 3 pi over 2, but less than 2 pi. So the range is between 3 pi over 2 and 2 pi.
Okay. That's so great. I love that circle. That makes sense. Well, let me ask you this. So that, not to make it more complicated, but if I wanted to try to figure that out on my own, would I not be able to put 295 times pi over 180?
You can do that as well if you'd
I
like.
got some weird number.
But you would get some weird number. So it's easier just to say, okay, where am I at? Okay.
Okay.
So another way to do it is, like, remember when we were talking about coordinates in first 9 weeks. We said the coordinate plane is divided into 4 quadrants. This is the first quadrant. This is the second quadrant. This is the third quadrant. This is the fourth quadrant. It's measured counterclockwise, the same way it's numbered counterclockwise, the same way we measure an angle. And that's the reason we measure it we number it counterclockwise, because that's how we measure our angles. Now, you have when you have an angle, we talked about 2 types of rays. We talked about the initial ray. We talked about the terminal end. So you see where your terminal array falls. So it's 295. It'll be greater than it'll be more than 270, but less than 360. So it'll be in the fourth quadrant. So it's between 3 pi over 2 and 2 pi. If it was like, say, 200, that means the terminal will fall in the third quadrant, which means that it is greater than pi, less than 3 pi over 2. If it was 120 degrees, that means the terminal end will fall in the second quadrant. So it's between 90 and 180, or pi over 2 and pi.
Okay. That's so great.
What are we even talking about anymore?
Maddie, are we the only ones on this thing?
No, but everybody else is muted, not showing their
Oh, okay.
So no, we're just going over
face.
the circles, because some of them, I guess, are actually done with circles, so I don't know.
Well, that's huge, because that's several questions. Or the first time I took the quiz, it was several questions. The last time I took the quiz, it was only 2, and I guessed right on one and I guessed wrong on the other one. But now I get it. Thank you.
No problems. Maddie, any more questions about circles? You said you had one?
Yes, I have another question.
Sure.
It says, an arc on a circle measures 250 degrees. Within which range is the median measure of the central angle? And then it gives me a bunch of ranges.
That's what we just did.
Is that what we just did?
Yep.
Yep.
Okay. So let me
So-
look at your little example here.
Yeah.
It's 250 degrees.
Okay.
So that would be between 180 and 270.
Right.
Which would be in between pi and 3 pi over
Right.
2.
Mhm.
Yeah. Oh my gosh, I answered it for myself. I got it right. I'm learning.
I have hope. I have hope. Hope, but a hope nevertheless. Yeah.
And then it's got a part with a clock. There's something with a clock.
Okay, read it.
The face of a clock is divided into 12 equal parts. If this is like an obvious question, I haven't read it yet, so I'm just reading it for the first time out loud. So like, don't get mad at me if I don't know the answer, because I'm just reading this. The face of a clock is divided into 12 equal parts. The radius of a clock face is 6 inches. Assume the hands of the clock will form a central angle. Which statements about the clock are accurate? Check all that apply. I hate these questions.
Okay, so let's do this. This is a really good question. Okay, I like these question types. Well, as I told you.
I hate the ones where it's like check all that apply.
So in a normal clock face, sorry.
Oh my gosh.
Okay.
Am I disturbing you? Okay.
Okay. So here's your center. What would be, so the big hand is on 12 and the little hand will say is at 1. What would be the angle measure here in degrees? Well, think about it. How many small little wedges do you have? If it's
12.
12 wedges. So each wedge is how many degrees? If there's 12 wedges, how many in a full circle?
360. So it's 12 divided by 360.
Well, 360 divided by 12, which is
That's the basic idea.
what?
I'm getting my calculator on my iPad. Hold on.
Really?
30.
Yeah. Now, how many radians is it? Well, remember we talked about how to convert degrees into radians.
Yes, we did.
So pi over 6, okay?
Okay.
Each angle is 30 degrees or pi over 6 radians. Well, what is the, what do they say the minute hand, the length of the minute hand was? Or the second hand, whatever the
I just know it says the radius of the clock hand is 6 inches.
6 inches. Okay, so this is say 6 inches. So how do I calculate the arc length?
The length equals circumference times A, angle measure.
Angle divided by 360, or radius times theta, which the angle in radians. So the radius is 6, and the angle measure is pi over 6. Okay. So that means if we do the math, each wedge has an arc length pi.
Each is equal to pi.
Each wedge is equal, the length of each wedge is equal to pi. The length of the arc measure of each.
But that's not any of my statements.
So what are your statements?
Yeah, I remember seeing this.
All right, I'm going to go A, B, C, D, and E because there's 5 of them.
Okay.
The
Do
first
not.
one is the central angle measure is when one hand points at 2 and the other points at 4, it's 60 degrees.
So 1 is 2 and 4 is 60 degrees. Well, think about it. If 1 is at 2,
Yeah, that's correct.
okay, so good.
Because they're 30 degrees individually.
Right. So there's 2 wedges, so 60 degrees. Good. Next.
The circumference of the entire clock is about 19 inches.
Okay. Circumference is what? What's the formula for circumference?
I don't think I remember.
Pi times the diameter.
Yes, pi times the diameter.
Okay, what is my diameter?
Your diameter is 12 inches.
Okay. And what is pi approximately?
3.14159265359 something.
Okay, so 12 times pi gives me what? It's 12 pi, but what is the approximate measure?
Times pi. 37.699111 bunch of whole numbers.
So is that a correct statement?
So are we rounding to the 10th place?
Yeah. So is that a correct statement?
No,
Okay. So 2 is not
not
right.
at all.
Okay. So
All right. The next one is with one hand at 5 and the other at 10, the minor arc formed by the hands is about 15.7 inches.
okay. So one hand at 5 and the other at 10. So the minor is the smaller arc. So remember, I told you each wedge is pi, right? So how many wedges do you have? 1, 2, 3, 4, 5.
Yeah.
That's 5 pi, and
5.
which is what? 5 times 3.14, which is approximately 15.7.
Oh, okay, then yeah, that's true.
Okay.
Cool.
4.
The minor arc measure when one hand points at 1 and the other points to 9 is 150.
So you do the
I
math.
can figure that one out. Hold on. 9 times 30 is, I'm gonna do this one in my head. I don't need the calculator. 9 times 30 is 9 times 3 is 27. I already know that's not right. So
What is the measure? What did they say it was, the minor arc?
150.
So is it right?
No.
No, it's not. Okay.
So that means, oh wait, the last one doesn't have to be because it doesn't give me a specific number. The length of the minor arc between 11 and 2 is the same as the length of the minor arc between 7 and 10. And that's true because they're all equal to 30.
Yeah. So 11 and 2. Okay. And 7 and 10. So
Oh, I got it right.
there you go. So it's just you walk through each one. Okay.
Okay.
Miss Lee, did that make sense
Yeah.
as well?
Yes, yeah, I did that one. The one thing that really got me was those range of measures. I just wasn't sure how I was supposed to be figuring it out.
And would it be the same if it gives me the arc measure in like centimeters and I have to get it in degrees?
Mm-hmm.
Okay.
They gave you the arc length, not the arc measure. The arc measure is the measure of the curvature of the arc. That's in degrees or in.
Oh, they gave me the arc length.
The arc length is remember that is radius times angle in radians, so equals 30. So if you know the radius, you can find the angle measure in radians, and if you know the radians, you can convert it into degrees if you'd like.
Okay.
You want to go through it?
Hold up. I turned my phone off on accident. Okay, I'm back.
Okay, you want to go
Just because it's confusing. Plus, I'm about to take the unit test, and I am not trying to fail. That's just not something that I'm trying to do.
Well, yeah, because whatever grade you get on the units test after one retake, that sticks no matter what you like.
Exactly. So I'm just not trying to do that. Okay.
I mean, like if you wait a week to take to do a retake, it'll.
No, I mean, like, for example, you take the test and say, for example, you get something below a 60. You're given one more retake and then that's it. And you can wait as much time as you want to do the retake. But, whatever, like normally for the quizzes, I was asking all my students to get 60 or above, and I was just giving them an ample amount of retakes until they got that. However,
Gotcha.
for the test, there is no such, leniency given. Whatever you get is whatever you get.
Okay.
So if you get like a 50, well, that's what after the retake is a 50. So,
Gotcha.
Yeah.
Okay.
Are we good? Or you want to go over it?
Let's go over it because
Okay.
I'm still confused.
Hey, Mr. Darianani, I'm going to hop off. Thank you so much.
No problems. If you have any more questions, just let me know.
Thank you.
Sure.
See y'all.
Okay, go ahead.
I'm really just holding this call up, but it's okay because I'm getting help.
No problem.
All right. So it says, consider circle O below. the length of arc BA is 8.4 centimeters, and the length of the radius is 8 centimeters, and the measure of angle AOC is 45 degrees. So I think I have to show you this one to like show you how the circle is set up.
Yeah.
If it's gonna flip. Did it flip? I don't know. Yeah, it flipped. Okay.
Hold on 1 second. Hold on to that. Don't. Okay, so let me draw this quickly. Give me 1 second.
My dog just came out of my closet and it scared me.
Okay, go ahead. I got it.
All right, cool. And it wants the measure of angle BOA.
BOA. Okay, BOA. All right. Well, I want you to look at this picture, and I want everyone else to look at this picture and sort of tell me. Let me share this. Hold on.
It's a two-parter. It also wants me to, and then it wants me to give it the length of arc BAC after that. So
let's do theta, and so we want to know measurement of angle theta and BAC. Okay. All right. So tell me how you would get the angle measure.
The angle measure?
Remember the angle theta. How would you look at the diagram and tell me, based on the formulas that we've talked about, how to get the angle theta? Let's worry about it. Go ahead.
Okay. You would like move the. Okay, Ave, just close the door. No, I'm on a Zoom call. Go. Jeez. Sorry. 8.4. You would translate your 8.4 centimeters to
Okay.
You would do the thing you just did with the pies and the.
Okay, so 8.4 centimeters. Is that the arc length or the arc measure?
That is the arc length, but we're trying to find the arc measure.
Right, or the angle, right? Because the arc measure and the angle is the same. So we know the length is 8.4 centimeters.
Yeah.
And we know the radius is 8 centimeters. And since they're both the same units, we can actually ignore the units for the time being. Okay.
Yeah.
Now, remember the formula. Length equals the radius times the angle that we're looking for, but the angle will be given to us in degrees. I mean, in radians. Okay. So plug it in.
Yeah.
8.4 equals 8 times theta. Okay. So we do the math. 8.4 divided by 8 gives me the angle, which is
8.4 divided by 8 equals 0.4. 1.4, yeah.
1.4, okay? Now, remember, this is in radians. So did they give the answer in radians or in degrees for theta? For the
degrees.
Angle? Okay, so we know that it is 1.4 radians.
Yeah.
So we want to convert it into degrees. So we multiply this by 180 divided by pi. Right? So what do we get?
Yeah. 180 divided by pi is
1.4. No, what would be 1.4? It would be 1.05, right? The theta would be not 1.4, it'd be 1.05. So 1.05 radians times 180 divided by pi gives me what, approximately?
okay. So I did 180 divided by pi, but I didn't do the 1.4, the 1.05, or whatever.
Yeah, 1.05 times 180 divided by pi gives me what?
Times 1.05. 60.16. Yeah, 60.16.
So let's say 60.2 degrees, okay?
Okay.
All right. So the angle is 60.2 degrees. Okay.
Mm-hmm.
What do they want the angle in whole numbers, or do they want like a decimal?
Let me look at my answer choices. They want it in whole numbers.
Okay, so about 60 degrees. Okay.
Okay, that is actually an answer choice.
Good. Now, we know this is 8.4. Now we want to know.
But the BAC, they want it in the. They want that one rounded to the nearest tenth of a centimeter.
Okay, so now we want to know. Now we know that. So we know that this is 8.4. Okay.
Mm-hmm.
And in order to find BAC, we need to know what AC is. We need to know what AC equals. Well, how do we get that?
Yeah.
It's the radius times theta.
You would take your 45 and you would convert it.
Okay, so 45, convert it. Remember, we multiply it by pi over 180. And that gives me 45 pi. Oops, not 4 pi. 45 pi over 180, which if we reduce 45 and 180, we get 1/4. So it's pi over 4. Okay, so radius is 8 times pi over 4, which gives me what? 8 times pi over 4, or 2 pi, which is approximately what? 6.28? So 6.3. So if we know this is 8.4, and we know AC is 6.3, then BAC would be
14.7. Cool. And that is an answer choice as well. And I got it right. I'm starting to see how this thing works.
not bad if you just took it.
The next one's got a whole hexagon in it.
Okay, so let's walk through it.
This is my last question on my
it's-
segment. It's a hexagon inside of a circle.
Okay.
Actually, I'll just show it to you.
Yeah. Hold on.
Yeah.
Okay. Let me write this down 1 second. So what do we call this polygon when all the vertices are on the edge of the circle? What do we say that the polygon is? Starts with an I.
Inscribed.
Inscribed, good.
It's in the question, but
Mhm. Okay, good. So what are my questions?
What's the measure of angle ACB?
ACB. Okay, so tell me.
Angle ACB is.
Look here.
Oh wait, there's no numbers. Like, how am I supposed to know that?
Oh, customer care. Mobile.
Sorry. Okay, now this is a regular hexagon, right?
Yeah.
What do we know about all these inside angles here?
Mm,
If it's a regular
they
hexagon, what do we know about all the central angles?
they are equal.
They're equal, right? Well, how many central angles are there?
6.
6. How many degrees in a circle?
360.
So each one,
360 divided by 6.
which is
This is the slowest calculator.
well, you don't really need a calculator to do it. It's basic math.
60.
Thank you. Okay, next.
Oh my gosh, so that was it. That was the whole. Okay, cool. What's the length of segment AB?
Okay, well, are there no numbers besides this?
Nope.
What does the instruction say?
Oh, yeah, there are. Angle C 60 degrees.
What else?
That's it.
Doesn't give you the radius of the circle or anything?
It says the radius is R.
Okay, so they want a formula for the. They want a formula for that, right?
Mm-hmm.
Okay, so.
Yeah, oh yeah, they want a formula.
Okay.
I could have checked that, I guess, yeah.
They want the length of the segment, right?
AB, yes.
Length of segment AB. So let me draw that out. Okay. Well, tell me, what do we know about this side CB and CA?
They are equal
Why are they equal?
because every single one of the little lines going across the circle are 180 degrees.
Oh, no. What do we call that line that goes from the middle to the edge of
Diameters.
not the diameter, middle to the edge?
The
Starts with an R.
oh shoot, radii.
Radius, right. So all the radii in a circle are always the same. So we know this is the same as this, right?
And all the other
What
ones.
type of triangle does BAC become if the two sides are the same?
Isosceles.
Isosceles. What do we call this line that comes from the middle and is perpendicular? It comes from the vertex and is perpendicular.
Bisector.
Well, more than that, it is called the altitude.
Altitude.
Right, right, right. Now, here's the thing. Okay. What does the altitude also do to the middle angle?
It bisects it.
Bisects it, right. Okay. And it also bisects the opposite side. Okay.
Yeah.
So we know this is 30. We know okay, so we know this is 30, this is 90, has to be
60.
so what that's a 30, 60, 90 right triangle, correct?
Mm-hmm.
So if the hypotenuse is R, what's the
Yo,
relationship?
go get your package.
Thank you. So what's the relationship between the sides of a 30, 60, 90? Do you remember this? This is a special triangle we talked about.
Yes, we did. It has been a while. I'm one of those people that remembers something for the quiz and then forgets it.
You do a data dump. Yeah. Okay. So remember in a 30, 60, 90, which is the smallest side in a 30,
The
60?
side on the back,
The side across from which angle?
30.
Right. So in a 30, 60, 90, you remember the relationship between the smallest side is x. The largest side, which is always the hypotenuse in the right triangle, is 2x. And the side across from the 60 is x root 3.
Ah, I see. I do remember that actually.
Right. Well, if the longest side is r and it's double the smallest side, that means the smallest side is r over 2.
Cool.
Well, r over 2 is just the length of this piece. That means this piece is also r over 2.
Okay.
So the whole length segment would be r over 2 plus r over 2, which is r.
R. Okay.
And you know this, look, and you know you could have done this a little bit faster by saying, okay, well, this angle right here is 60, and this angle right here is 60. What is this
Yeah.
angle? It's 60. So what type of triangle do we have whose angles are all 60?
Equilateral.
Equilateral. And all the sides of an equilateral triangle are what?
Equal.
Are equal. So if one of the sides, which is the radius, is r, that means
Oh my gosh.
area.
Yes, that is true.
It's all coming together.
It is. Okay. Well,
I know,
what's
we
the
liked it.
what's the perimeter of the hexagon?
Okay, well, you tell me. If one of those sides, AB, is r, then what's the perimeter of the hexagon?
6R.
Good.
Okay. The perimeter of the hexagon is blank the circumference of the circle. Okay. So the answer choices are slightly greater than, slightly less than, or equal to the circumference.
Okay.
So is the perimeter greater than, less than, or equal to the circumference of the circle?
What is the circumference of the circle? What's the formula for the circumference of a circle?
We just did this. The circumference of it is the radius times the diameter
No.
over 360.
No.
No, over times pi. Radius times pi over.
Not radius times pi. It's pi times the diameter. But how is the radius and the diameter related?
The radius is half the diameter.
The diameter is half the radius.
Yes.
Okay, so that means 2 times the radius gives me the diameter, right?
Yes.
So this is 2 pi r, okay? So you got a circumference that's
Mm-hmm.
pi r, and you got the perimeter, whose formula is 6 pi, right?
Mm-hmm. Yes.
No, not 6 pi, but 6r, sorry. Okay, perimeter is 6r. That's the formula that you gave me, right?
Yes.
Okay, well, tell me which is bigger. Well, how do you find it? Well, plug in a number for r. Give me a number for r. It doesn't matter which number it is.
3.
3. Okay, so the circumference of the radius was 3 would be 6 pi, which is 6 times 3.14, which is what, for 18.84.
Mm-hmm.
And the perimeter would be 6 times 3, which is 18. So you tell me, which is larger, the circumference or the perimeter? In this case, if the radius is 3.
The circumference.
Okay, so what would be your answer? What would be your answer choice?
The perimeter of the hexagon is less than the circumference of the circle.
There you go.
I have one more.
Okay.
The circumference of the circle is, wait, this is literally what we just did. It's slightly greater than 6r, slightly less than 6r, or equal to 6r. We just did that.
Slightly.
Okay, cool.
Yeah, there you go.
Yeah, okay, I got that right.
Mm-hmm.
And now I'm at 26%.
Good.
Okay, cool. Yeah, that was all my questions.
Cool. Well, I was going to talk about density and changing, doing, what was that? What was the called? Density equations and surface area and cross section and unit conversion equation formulas. But we'll just pick that up tomorrow if nobody has any more questions. Any more questions, Maddie?
I'm out of questions.
Any more questions from anyone else?
Like,
Well, that was a pretty good thing. I mean, a lot of people need a review because not everyone's done with the circles unit test.
yeah.
So, that it is a legitimate question and how all these things are related. Because it would be a topic that I would not have covered in class because there's no guarantee everyone's going to go to Algebra 2 with trig. So, which I love this stuff, as you can tell. I'm like a pig in slop in this stuff. So,
Oh my gosh.
yeah.
Man, you could just do my work for fun then.
Yeah, I do it for fun. I enjoy it. I actually take the tests and the unit tests for fun anyways. So.
Ugh.
All right, so if there's no more questions, then I will see everybody tomorrow, and I will upload this in a couple of seconds onto Google Classroom and onto the YouTube page, Professor in Pajamas. Remember,
Cool.
all this stuff is going to be due not this Sunday, but next Sunday. So if you go to iNow, all of the grades that you've given me up to now are in. So as of next Sunday, if nothing goes in, those grades are going to be, those things that are blank are going to be replaced with zeros, and that's going to plummet some of your grades. So please
All right.
stay on top of it. All right?
Cool.
More questions? All right. Y'all have a nice day.
All right. Bye. Thanks.